All right, today we're jumping into one of the biggest headaches in modern software. How in the world do you keep your data consistent when it's spread across a bunch of different services? We're going to follow a couple of engineers as they figure this out using a really powerful idea called the Saga pattern. So, let's get right to it.
So, it all starts with a crisis. This is the exact moment that gives e-commerce developers nightmares. We've got an engineer, Timothy, and he's just realized that his shiny, fast, decoupled microservice architecture has a huge flaw. A payment went through just fine, but the product was actually out of stock. So now the whole system is in this weird, inconsistent state, and you've got an angry customer. This is the exact problem we're here to solve.
So how did this even happen? Look, this isn't just some simple bug. It's a fundamental problem that pops up the second you move away from a single big system to these modern distributed ones. And to really get the solution, we first have to unpack exactly where things went wrong.
Okay, here's the play-by-play. First, a customer orders a cool mechanical keyboard. The payment service, which is its own little microservice, does its job perfectly. It charges the credit card. Success! But then, just a moment later, the inventory service, a totally separate microservice, wakes up and realizes, uh-oh, we're actually sold out of that keyboard. So the order fails, but that charge? Yeah, that's already gone through.
The really wild part about all this is that in an older, more traditional system, what we call a monolith, this problem is, well, it's not a problem at all. You'd have just wrapped the entire checkout process up in a single database transaction. If any piece of it failed, like checking the inventory, the whole thing would just automatically roll back. No charge, no failed order. Simple. But in the microservices world, you just can't do that.
And this is exactly what Timothy's senior colleague, Margaret, tells him. See, this isn't some rookie mistake he made. It's a famous, incredibly tough challenge. You can't just stretch a database transaction across a bunch of separate, decoupled services. You need a totally different way of thinking.
And that new way of thinking? It's called the Saga pattern. This is the solution that lets us manage a business transaction that spans multiple services, making sure our whole system stays consistent even when things go wrong.
So, what exactly is a saga? Well, think of it like a story with a bunch of chapters. Each microservice handles its own little piece of the story, its own local transaction. If all the chapters complete, great, we have a happy ending. But if one chapter goes wrong, the saga basically starts telling the story backward, undoing each previous chapter to get everything back to how it was at the start.
And those undo steps have a special name, compensating actions. Now, this is a really key point. A compensating action isn't just a simple rollback. It's a whole new transaction that explicitly reverses something that already happened. So, if reserving the inventory fails, the compensating action is to actively issue a refund. That's how we clean up the mess and get back to a consistent state.
Okay, so this is the next logical question, right? We've already got tools that pass messages and events between our services. Why can't something like that just manage this whole thing? Well, it turns out there's a world of difference between just passing a message along and actually managing a complicated workflow. And that brings us to a really fundamental choice in architecture. Do you want your services to be choreographed, or do you need them to be orchestrated? Because your answer to that question will decide whether or not you can even build a saga.
This chart just lays it out perfectly. On one side, you've got choreography, which is what you get with a tool like AWS Event Bridge. It's stateless. It's kind of like the Postal Service. It just delivers a message, but it has no idea what the bigger picture is. Your services just react on their own. On the other side, you have orchestration, using the stateful manager like AWS step functions. This is completely different. This is like the conductor of an orchestra. It knows the whole piece of music, it's telling each section exactly when to play, and it knows precisely what to do if someone hits a wrong note. And that's exactly why a saga absolutely requires orchestration. You need that central conductor, that brain, that remembers the state of the entire process, what worked, what failed, so it can intelligently command those rollbacks when things go sideways. A simple stateless router just can't do that. It doesn't have the memory.
So how do we actually build this conductor? Well, Margaret shows Timothy how to do it using a service that was purpose-built for this exact job, a state machine.
So inside AWS step functions, you basically have two main flavors. You've got standard workflows, which are perfect for really long, auditable processes. They can run for up to a year. But for something fast and high volume, like our e-commerce checkout, an express workflow is the perfect fit. It's lean, it's fast, and it's cost-effective.
First things first, you define the happy path. This is what you want to happen when everything goes perfectly.
The state machine kicks things off by commanding the payment service to charge the card. If that's a success, it then commands the inventory service. If that's also a success, it moves on to shipping. See? It's a clear sequential commanded process.
But of course, the whole reason we're doing this is to handle the unhappy path. I mean, what happens when one of these steps eventually, inevitably, fails?
This is where the orchestrator really proves its worth. The state machine is built to listen for specific errors. In our case, the inventory service fails and throws an out-of-stock exception. The state machine sees that and immediately slams the brakes on. It doesn't even try to go to the shipping step. Instead, it shunts the whole workflow over to an error path where it executes our compensating action, refunding the payment. Just like that, the system is automatically put back into a clean, consistent state.
And here, Margaret drops a piece of advice that is absolutely crucial for any engineer building one of these. Your compensating actions, like that refund function, have to be idempotent. Now, that's just a fancy way of saying that if you accidentally run it more than once, it has the exact same result as running it just once. This is so important because if that refund action itself were to fail and need a retry, you really don't want to accidentally refund the customer 2 or 3 times.
You know, the payoff for doing all this goes way beyond just automatic rollbacks. It gives you something that's just priceless in a complex system: total clarity.
This is the real magic of using an orchestrator. It doesn't just run the workflow. It gives you a perfect record of everything that happened. It holds the state, it can handle temporary glitches with smart retries, and it gives you this beautiful visual audit trail of every single transaction. You can literally see exactly what happened, step by step. It brings an incredible amount of clarity to what would otherwise be a very confusing process. And this is the aha moment for Timothy. He's looking at a test run that failed in the console. He sees the inventory step turn red, but then he sees the refund step turn green. Yeah, the order didn't go through, but that's actually a good thing. The system did exactly what it was designed to do. The execution failed, but the data is perfect. No angry customer, no engineer getting paged in the middle of the night to do a manual cleanup. It just worked.
And that really is the question to leave you with. It's pretty easy these days to make your services decoupled and independent, but using the Saga pattern with a proper orchestrator is what takes you from being just decoupled to being truly resilient. It's how you build systems that can handle the messy, chaotic reality of failure with some real grace and precision.